Hi guys and welcome to learntocreategames.com. Today we'll be looking at raycasting and the idea will be to detect objects in a distance. So let's get started. So first what we will do is create a very simple environment. Again, as always, we're going to create the ground, so from a very simple 3D box, a cube. Resize it on the X and Z axis by 100. So again, first, before we actually do that, we're going to rename these to ground. Then change the scale properties to 100 on the X and 100 on the Z. So let's zoom out a little bit. Then I will create three other objects, actually four, that will be used as targets. So again, create cubes again, change the name to target, and after that what we will do is just to simply resize these boxes to scale it on the y-axis. So first put them just above the ground. Then what we may do is add a bit of color to these boxes, but before that let's just rescale them. Okay, so again about 7 meters on the actual y-axis. And then we will just pick a color. So again, I have a material ready and I will actually just take it and drag and drop it onto this object. You can create your own material if you want to, using the create and then material from the project menu. So once this is done, the next thing you need to do is to duplicate this object. So before that, I'm going to create a folder called Raycast or Raycasting. And when this is done, I will add any behaviors or script to this folder. But before that, I'm going to add a tag to my object. So again, I have a tag that exists already. It's called target. I'm showing you here, or you could have created this tag if you wanted to. So again, select the object and select target for the tag. So when this is done, we're pretty much ready to go. We just need to duplicate this object 3 times. So again, by default, Unity will add 1, 2, and 3 to the name of the appended object. So again, target 1, target 2, and target 3, and target 4. Again, I will move them around so we can see them. Okay, so now we can see those 4 targets. And again, because my first target had the label already, I should be able to have the exact same label on those 3 other targets. Now what I need to do is add a first-person controller. So again, I downloaded the asset characters, and in this assets, which is a standard asset basically, I can add the FPS controller, which is a first-person controller. So once this is done, I can play my scene to ensure that my first-person controller is above the ground and that I can see the different targets. So again, after pressing the play button, what we should be able to do is to move around the scene and also look at the different targets. So again, as the scene starts, you can see that I can move around with my first-person controller and see the different targets. So once this is done, now I can create my script, and this script will have for purpose to detect whenever one of these targets is in front of my character. So again, I'm going to create a brand new script in my folder. The script, I can call it Raycasting, for example, and then double click on it to be able to edit it. So again, full screen. So the first thing we will do is create a ray. So a ray again is like a beam of light that has an origin and a direction. So again, the type is ray, which is fine. And then what I need to do is to create this ray, so set its direction possibly and its origin, and then cast this ray from the center of the screen. Okay, so again, we use a function called screen point to ray. And what this does, it creates a ray from a particular point on the screen and going outwards. So in our case, we want this ray to start in the middle of the screen. So again, the position will be defined by the X, Z, and Y position. So the X will be half the width, the Y will be half the height, and the Z will be set to 0. Okay, so again, because this script will be linked to an object that has a camera, we will actually select getComponent.camera. We're accessing the camera that is a component of the object linked to the script. Then we use the function screenPointToArray to create an array that will actually start in the middle of the screen. So again, screen width divided by 2. and screen height divided by 2 and 0 for Z. Now there is a small little change to add to that. You will see there is an error later on. It's that I need actually to create a vector from the X, Y and Z position that I've defined. So we'll see that later. Next, what I do is I create an array. So again, this array here is just for debugging purposes, which means that you're going to cast array. So again, you specify the origin, the direction, and then the color. So you will only be able to see this array in the scene view, not in the game view. Now, as I do that, you can see that there is actually an error there at the bottom of the screen. So again, I need to go back to this code and just change this line 8, where basically I need to set a vector tree, which is a vector defined by 3 coordinates, x, y, and z axis. Okay, so again, I'm missing again the closing round bracket, so I just need to add it at the end of the line, and we should be okay to go after that. So again, this error should disappear. Done. So at this stage we should be okay to play the scene. So again, we have an array that is been created, and this array basically is used first to create a kind of array to debug the code. So in other words, in the scene view we should be able to see this array. So I'm not casting this array yet to look for objects. I'm just casting array for debugging purposes. So again, you're going to be able to see that as I play the scene. I will actually have to divide my screen in two. So again, put the scene view in different location, so that as I move the character in the game view, you should see the raycast. Even you can see it now. You have a red line that is coming from the camera that is associated with the first-person controller. So if you look at the bottom of the screen here, you should see that this red light is moving around as my game view is changing as well in the game. Okay, so again, as I move in the game, you could see this array and the scene view is moving. So again, you won't be able to see it in the game view because it's kind of debugging mode. Okay, but what I will do next is to show you how you can create an invisible array then that will make it possible to detect the object in front of you. So to cast this array, we need to use what is called physics.raycast, and physics.raycast will basically cast array that will basically detect objects that have a collider. So here I'm just saying that if I'm casting array and that something is detected, then the system will send the information related to this collision in an object called hit, the object I've declared at the very start of the script. So again, I'm casting the array, and hit should return information about the collision. And one of the things I can get from this object is the collider involved in the collision, so the other collider, and then the game object that is linked to this collider. So in this case, I will say the object and then the name of the object that my array is colliding with, and then add something like is in front of the player. So again, you won't see this array. The debug array will help you to do so, but in the play view you will not see it. In the game view you won't see it. However, now if we play the game again and look at the console window, you know that now my targets now target 1, target 2 and target 3, which means that whenever I am in front of them, whenever they are in sight, the console window should tell me accordingly. So again, as I move around here, you should see that as I get closer to this object, they should appear in the console window. You see that the actual console window will display the name of the object that is just in front of me. So we go. So again, the object target 4 is in front, the object target 1 is in front, and then 3 and 2 again. So again, this is working perfectly. I've managed to detect the object that is just in front of me. So now what I'm doing is just collapsing the view a little bit, so that basically we can see it a little bit better and sequentially as opposed to all those compacted into one message. Well, that's it guys. I hope you enjoyed this tutorial, and again, if you want to learn more about Unity, please check the website learntocreategames.com. See you. Bye.